Optimus Prime! Optimus Prime!
5.7 meters above sea level, 2932 north.
Kill track, 5205 the cut.
Target acquired. Killing track
2, 1, fire.
Bro, wake up. We need to go to class. We are already late. Go.
A few moments later.
Hey bro, I had this crazy dream today. There was this missing weapon. It looked so powerful, like something straight out of a sci-fi movie. I'm pretty sure that it was from Transformers. I think it's called a Railgun or something like that. I don't know, but it felt so real. It looks like you use some kind of advanced technology.
Oh, no wonder you mumbled in your sleep. You probably watched Transformers last night, right? That's why you overslept. But the weapon you said is really cool though. Let's find out more together.
The first thing you need to know, Railgun is a type of electrical weapon that uses neodymium magnets. This is a permanent magnet and electromagnetic force. There's two magnetic components in the railgun. The first thing is rails. Rails is two long parallel conductive metal bars. Rails function when high electrical current accelerates through the rails, it will generate magnetic fields. Next, capacitors. Capacitors function when after the weapon being charged, capacitors send an electrical impulse down two long rails, one negatively charged and one positively charged, generating an electromagnetic field.
This is the general concept used in railguns. When a metal is placed on the wire, a current will flow from the positive terminal to the negative terminal. When the current flows through the wire, magnetic field is now created around the wire. By gripping the wire and using the right-hand rule as shown, we can determine the direction of the magnetic field. Due to the interference of these magnetic fields, the direction of the magnetic field is generated as shown. As we can see, it is going up. By using Fleming's left-hand rule, we can determine the direction of the electromagnetic force. The rule is as shown on the left. The thumb is for the force, the index finger is for the magnetic field, and the middle finger is for the current. To find the direction of the force, place the hand as shown on the picture on the right. The yellow dotted line shows the movement of current. Based on Fleming's left-hand rule, we can conclude that the force will push the rod forward. Thus, in the case of railguns, the projectiles will move out of the turret following the direction of force created. For the type of magnet used in railguns, it is called the neodymium magnet. As shown in the picture, it has a lot of shapes and sizes. The most common one used for projects concerning railguns are the circle-shaped ones. Its role is to provide a static magnetic field, which will then interact with the current flowing through the rails. A static magnetic field can improve the projectile's acceleration and efficiency, as well as enhancing the electromagnetic force.
Importance of magnet in railgun. Railgun depend entirely on magnetic properties, and this greatly enhances its efficiency, performance, and safety. Therefore, the main reason magnetism is essential in railgun is to generate magnetic force. Magnetism plays a vital role in the operation of a railgun. The main principle behind it is the Lorentz force, where a strong magnetic field interacts with an electric current to propel a projectile at extremely high speeds. Therefore, without magnetism, the Lorentz force wouldn't exist, and the railgun wouldn't function. Other than that, magnetic fields allow the projectile to be accelerated to speeds of over 7,000 km/h, far faster than traditional firearms. This makes the railgun highly effective for long-range and rapid attacks in military use. Lastly, presence of magnetism in railgun eliminates the need for explosive. Since propulsion is magnetic, there is no need for chemical explosions. This improves safety, especially on military ships or stations where explosive storage is dangerous.
The application that we choose is military application. The first one is naval railguns. The US Navy has tested electromagnetic railguns capable of firing projectiles at hypersonic speeds, which is Mach 6+, offering long-range, precise firepower without the need for explosive warheads. The second one is defense systems. Railguns could replace traditional artillery, reducing reliance on chemical propellants and increasing safety due to less explosive material. Next, impact on technology and society. Military strategy could reshape naval warfare by enabling faster, more accurate, and longer-range weaponry. And the last one, Significance of magnet in railguns. Railguns operate by using a powerful electromagnetic force generated between two parallel rails. When a current passes through the rails and a conductive projectile, it creates a magnetic field that propels the projectile forward at incredible speeds.